Hello, honors kids. Good to be back together. Our second day of getting you guys ready for the fall in Algebra 2. Day 1 we dealt with all your exponent rules. Now the rest of the unit, I know you're going to be so happy to hear this, is going to be all the different ways to factor. Now again, you probably saw these a bunch in Algebra 1. And today's factoring, guys, we've been doing all year long in geometry. All right, I've been trying to get you guys ready for next year. There's 3 methods we're going to go over today. First one is a GCF. Is there a number or variable you can take out right at the beginning? Next is when a equals 1 and you're doing a trinomial where it has 3 terms. So that's your multiply to C, but adds to B. We've been doing that all year long. And then one we haven't really been touching upon, but it's not too bad, is difference of 2 perfect squares. Okay. First thing I just want to, and if you want to make a note of it would be great. Difference. It must be subtraction. Okay. If you see addition in between, no good. Can't do it. Difference of 2 perfect squares. And we'll talk about perfect squares here right now. You'll see 9x squared. I'll write it out so we can start it fresh. 9x squared minus 16y to the 4th. First, 9, 16. Those are perfect squares. I can take the square root of them. Anything that has an even exponent, all right, even exponent is considered a perfect square. Okay? 2, 4, 6, 8, 10, 12, etc. Any even exponent is considered a perfect square. Okay? And we'll get in how to factor them in a second. So it's got to be subtraction, and the variables have to have even exponents, and the numbers themselves have to be perfect squares. All right, the numbers out in front, like we had 9 and 16. All right, let's do this. Let's roll through these. Here we go. Number 1, x squared plus 2x minus 24. Always look for a GCF first. Is there a number I can take out of any of those? And in this case, I cannot. Do they all have x's in them? No, they do not. So I can't take out an x. But it is a trinomial where the leading number out in front is 1. So just like we've been doing all year long in geometry, we can play a little game. 2 numbers that multiply to negative 24 but add to 2. And again, you're in honors. You're going to be going to Algebra 2 next year. None of your teachers next year want you to do that y equals trick on the calculator. All right. And if you have no idea what I'm talking about, good. All right. That's a good thing. So don't be going to your y equals screen and 24 divided by x. Let's see 2 numbers that are 2 apart. Get out of here. All right. Get out of here. 6 and 4 are your numbers. Plus 6 minus 4. Okay. Number 2. Let's see. Any GCF in number 2? Nope. They both don't have the same variables, so there's nothing I can take out there. But now here's what we're talking about. You see the subtraction in between. What do you guys know about 144? It's a perfect square. What do you know about a squared and b squared? That is also a perfect square. So we are going to use the method difference of 2 perfect squares right now. Okay? So let's take care of the 144. What's the square root of 144? 12. So I plug 12 and 12 into there. How do you deal with a squared and b squared? Well, ab and ab. If you wanted a little quick trick in a nutshell here, divide those exponents by 2. Divide the exponents by 2. All right. And then if you remember from Algebra 1, when you do this method, difference of 2 perfect squares, the signs in the parentheses always must be opposite each other. So one's got to be addition, the other's got to be subtraction. So there's difference of 2 perfect squares applied. Okay, number 3, again, look for a GCF. Now there is a GCF. What can you take out of 2, 6, and 18? You can take out a 2. All right, can I take out an x? No, I cannot because the 18 does not have an x. So what I'm going to do is, all right, here we go. I'm taking out a 2. So I'm going to basically divide all these terms by 2. So when I take a 2 out of the first one, you're left with x squared. A 2 out of the second one, minus 3x. A 2 out of the last one, minus 9. And anytime you do GCF, you want to just take a quick look inside the parenthesis to make sure you can't factor what's left. Anybody know two numbers that multiply to 9 and are 3 apart? Me neither. So we're done. Okay, we are done here. All right, next up, 3x squared minus 12x. It's going to be a broken record. I apologize, but look for a GCF first. You can take out a 3 from 3 and 12. And now, for the first time, they both have x's in them. So I can take out an x. So if I take out a 3x from 3x squared, remember, you're dividing them from each other. You're just left with an x. And then 12x divided by 3x is minus 4. Nice and quick there. Okay, number 5. You can see I can take out a 4 first. So I'll take out a 4. And then you'll be left with x squared minus 5x plus 6. Remember what I said. Anytime you take out a GCF, can you factor what's left? And in this case, you're darn right I can. Be careful here. This is always a tricky one. Think about two numbers that multiply to positive 6, but add to negative 5. Add to positive 6, but multiply to negative 5. And your numbers are 3 and 2. How can you get them to multiply to positive 6 but add to a negative 5 if they're both negative? And do not forget to keep bringing down the GCF in your answer. Okay, because this is what I'm going to be looking for. That's your final answer. Okay. All right, moving on. Any GCF here? No GCF to take out in number 6, but you do notice hopefully 100 is a perfect square. X squared is a perfect square, and you're subtracting. So this is difference of two perfect squares. Now, you may not like the order it's written, but what number is first? It's 100. So that means I'm going to do the square root of 100. I'm going to put the tens first, not last, first, because the 100 came first. And then I'm going to put my x's second. And what did we talk about in problem number 2? Anytime you do the difference of two perfect squares method, the signs are opposite each other. Okay? So if the number comes first, so do your numbers. Variable comes second, so do your variables. All right. Everyone always gets mixed up with number 7. Always gets mixed up with number 7. They see 36, they see 100, they see c squared, and they see d squared, and they're like, here we go, perfect difference of two perfect squares. Let's roll. Sorry, it's not difference of two perfect squares. What do I always ask you to look for first? G, C, F. There is a number that goes into 36 and 100. And that number, think the biggest number is 4. So I'm going to take out a 4 here and be left with 9c squared minus 25d squared. Now what's left inside the parentheses? Are perfect squares. So now you can use difference of two perfect squares. 3c plus 5d, 3c minus 5d. And then again, just keep bringing down your GCF. Okay? Now, would you have been wrong if you did difference of two perfect squares at the beginning? No, you wouldn't have, but you would have noticed what you had in your parentheses would still have a GCF you could take out. So it wouldn't have been wrong, but you would still have a GCF you had to take out. Okay? All right, so what I want you guys to do right now is do 8, 9, and 10 on your own and see how you do. Look for a GCF. Can you go further? If you can, go further. All right, so take a look at 8, 9, and 10 on your own and see. We'll get back to each other here in a minute and see how we did. Go ahead, pause the video. We'll be back in a minute. All right, guys, so hopefully we came up with matching answers here. For number 8, you had to take a 3y out first as your GCF. And then inside your parenthesis, you would have had y squared minus 64, which would be difference of two perfect squares. Just make sure you keep bringing down that GCF all the way down. Number 9 had a GCF of 2x, and you were left with x squared plus 3x plus 1, which could not be factored anymore. And also, just a quick comment here. When you take a 2x and then you had this at the end, you're not left with nothing, remember. All right, so you shouldn't have just had x squared plus 3x, because remember what you're doing to each of these. You're dividing each of these terms by 2x. And when you do 2x over 2x, that ends up being the 1. So that's where that 1 came from. And then finally, number 10, you could take out a 4, an A, and a B. So you ended up with B minus 3A. Okay, so hopefully that helps, and you're ready to go on to packet page 8, which again does not look like much at all. Okay, so GCF, multiply to C, add to B, and difference of two perfect squares. You guys should roll right through this. Shouldn't take you more than 10, 15 minutes. All right, guys, good luck. I'll see you at the next Google Meet.